So, in last class, we actually discussed about the continuous random variable and all those different things. But means I told especially now you can solve questions from the paper itself. So if you go to the paper, you'll all find a lot of questions related to continuous and discrete random variable. And at this point of time, you can actually solve those questions by yourself also, because especially like questions like this can be once it will be solved, once I will teach you the this standard distribution. Okay, so after that this will be solved, but once before that you can solve other questions related to this continuous random variable, discrete random variable, or anything related to random variable. So we will see some questions, but first of all, just let's for now just like this question. So for that, for this, let's discuss something about called mathematical expectations, because I saw that in some particular questions they have asked about the mathematical expectation. And generally mathematical expectation nothing, if you are just finding the mean of a particular random variable x, that is expectation of x, that is called mathematical expectation. And in general you can find the mathematical expectation of any power of random. It's not like only the expectation of x. So let x be a random variable with probability density function fx. So means once you know the discrete and random variable and this continuous random variable, now you will have means the questions will be given something like this: lets x be a random variable and its pdf or pmf is fx. Okay, so this particular thing will be, you have to keep in mind that for particular random variable x, this particular thing is its pdf, probability density function or probability mass function, whether it's a discrete or continuous. So in discrete, it's called probability mass function, and in the continuous, it's called probability density function. And yesterday, I told you that if you want to find the probability density function, actually, if you just plot the curve, the probability density function, this the any particular probability, let's say probability x greater than equal to a. This particular probability is nothing but area under curve, this particular region. Okay, so this thing will be there, and once you will study the normal distributions, yeah. Actually, cannot do anything. My network is weak, so I cannot do anything. Okay, so network is weak, so I sorry for that, but I think it should be better now. So just let me do one thing. So, okay, better. So if you all can hear me now, just let me know. I will start. Okay, so I was telling in mathematical expectations, if you want to find a mathematical expectation of any random variable x, so x can be discrete or x can be continuous. So if x is a continuous random variable, the mathematical expectation is nothing but integrate the whole x into fx dx, and if you just integrate it over overall infinity minus infinity to infinity, you will get the mathematical expectation of a continuous random variable. So I have discussed this particular thing earlier also, and for any discrete random variable, just you need to replace this summation, sorry, this integral sign by the summation, and you will get the mathematical expectation of this discrete random variable. So anytime like if you have a random variable x and they want to find you the expectation of a random variable, then simply what you need to do is just whatever this integral is, just calculate this integral, and there you find the mathematical expectation of x. So the thing is that this particular limit minus infinity to infinity can be can be broke down irrespective to the definition of fx. Like yesterday we saw that if fx is something like this, if fx is something like this, you can here see that the x means the fx is only defined between minus a to a. Okay, so this particularly thing will be there. So this is a cumulative density function, but obviously fx, if you find the probability density function, it will be between minus a to a. Similarly, if you just go to some other questions like any questions like this, you can see that if this particularly fx is defined only before x greater than 0. So indeed, this case minus infinity to infinity does not make sense. Okay, so here you just need to do the whatever the range is given for that particular x, that you need to do those things. So this is the general definition that you need to integrate it between minus infinity to infinity. But this limit will be depend upon whatever the definition of fx is and whatever the limit of fx is. Okay, so there are actually some properties of expectations that you need to know, and those properties are actually very simple. I'm not going to prove this because obviously you don't need proof of anything. First thing is that let's say x and y are two random variable with you, then expectation of x plus y. So if you are just trying to find the expectation of the x plus y, it is actually the expectation of x plus expectation of y. So this thing is there. So if you want to find expectation of x plus y, it is expectation of x plus expectation of y. So obviously proof is very simple, but means you have to remember the result. The expectation of x plus y you want to find. This is this particular thing. Just find the individual expectation and add those individual expectations, and it can be generalized for the entire let's say you have a n random variable x1 to xn. Okay, so it can be generalized for all those random variables. Just if you want to find the summation of n random variable and find those expectations, the simple thing is that just you need to replace it by the summation of all the individual expectation. So essentially this is expectation of x1 plus expectation of x2 plus expectation of xn. Okay, so this particular thing reduced to this particular thing. Okay, so this in general is true. If you want to find expectation of any particularly random variable, the sum of random variable, just you need to find those means it just need to calculate the random variables expectations individually and add those expectations. And it's not like the plus, if it has in a minus sign also, you can just replace it with a minus sign. There is nothing to worry about it. Okay, and next important thing is about the independence of random variables. So let's say you have two random variable x and y, and you know that your random variable expectation of x into y, so expectation of x into y is expectation of x into expectation of y. So in that case you can say that your random variable are independent. So let's say you get two random variable x and y at any point of time, and they're asking if both random variables are independent or not. So what you need to do, you need to find expectation of x into expectation of y. This is going to be some value, and then expectation of x, it is going to be some value, multiply by expectation of y, it is going to be some value. If both these values are equal, you can say that your x and y are independent random variable. Obviously you won't find questions of this type in your paper, but obviously means this is something that you know, and maybe if time permits we will do some questions on the basis of this also. So this is just a properties of mathematical expectations that you need to know. So the first is the summation and second is the multiplication, and if it's equal, it tells you that both the random variables are independent. Obviously, the third properties is about like if let's say you want to find the if a is a constant and x plus b, so x is a random variable and a is a constant and b is also a constant. So in that particular case, you can say that your expectations is going to be like first of all this expectation is going to break. Okay, so this will be expectation of ax plus expectation of b. Okay, so any constant random variable does not have any expectations, means it's going to be the same number. Okay, and a random variable, if it is expectations, it means that you need to put the constant outside of the expectation and need to find the expectation of x only. So this is going to be the expectation of x plus b is a into expectation of x plus b. So obviously constant, whatever constant you get, just try to put it outside of your means whatever the expectation is, and then separate the constant out. So this is three important properties of mathematical expectation that you should know. Obviously the overall formula is to just use this particular thing to find expectation. In general, if you want to find expectation of x to x square or expectation of x cube, similar thing, just you need to put here a square or just you need to put here a cube, whatever you want to find it. Okay, same thing is going to work. Just change the value of this particular thing. So this expectation of this x square x cube will be depend upon this particular thing, whatever your here it is. So expectation of x square means nothing but x square into fx dx, or integral over minus infinity to infinity. So this thing is going to be there. Okay, some general formula is that expectation of 1 by x is not equal to 1 by expectation of x. So expectation of 1 by x is entirely different thing, and 1 by expectation of x is entirely different thing. So these both are not equal. So this I have given to like you should not consider, if you just let's say you want to find expectation of x to the power means anything, like let's say you want to find expectation of 1 by x. It does not mean that you need to find the one, means to find expectation of x, and what you do, you divide it by 1 and just means 1 divided by expectation of x indeed, and you find that this is the same thing. So this is not the correct thing. So this both the things are not the correct. So this you have to consider that whatever function it's given, just need to find on the basis of that. It's not like you want to find expectation of log x. So you want, what you did, you just find expectation of x and did the log. So these both are not the same thing. These are two entirely different things. Similarly, expectation of x square not equal to expectation of x whole square. These four things are not equal. These both means whatever left in the left hand side is entirely different from whatever written in the right hand side. So all those are different. This you don't assume that these both are the same. It's not true. Okay. So these four properties will allow you to, it can be, it sometimes can be asked in the questions in the MCQ itself, which of the following is correct, or which of the following is incorrect, and it may be given some three option or some other two option. Okay, so just a little introduction of covariance and correlation coefficient. Covariance is if you have two random variable x and y. So covariance between x and y is defined as, so it is written as COB x comma y. This thing is not been asked, but just know the definition, nothing more. So covariance is defined as, covariance of x comma y is defined as, you have to take the expectation. Okay, you have to take the expectation of what? Just x minus expectation of x. Okay, this thing is going to be there, multiply by y minus expectation of y. Okay, so this thing is going to be, just take the expectation of product of the difference between random variable and their expectation. So you can see that x is a random variable, expectation of x is expectation, y is a random variable, and this thing is expectation. Just you find the difference between these two things, then multiply the both the thing, and then you take the whole expectation. This is termed as covariance. So covariance correlation coefficient will be more used when you will just it may sometimes may be used for data science exams, other data science exams, if you want to sit for other colleges. But obviously, in semi paper, I have not seen anything related to covariance and correlation coefficient till now. But yes, if you should know this particular thing, and this is how it's calculated. This is how it's formalized. So we will see some example later, but for now, just don't. We should not waste our time on this thing. And simply the correlation coefficient is represented by rho x y. It means that there is a correlation coefficient between x and y. We want to find the correlation coefficient between x and y. It is nothing but covariance of x and y by sigma x, which is called a standard deviation. A standard deviation of x, and sigma y is called a standard deviation of y. Okay, so this particular thing is termed as correlation coefficient. Okay, so simple thing, obviously nothing will be there from the, at least something, some questions will there from mathematical expectation I've seen. But talking about the covariance and correlation coefficient, they are nothing asked till now, past 3 or 4 years. But the main thing is that you have to remember the things, if in case something is asked, some basic questions can be asked based on those things. So one thing you can see, that we exclusively told that if the two random variables are independent, then expectation of x into y is equal to expectation of x into expectation of y. So if two random variables are independent, then you can see that the covariance of x and y, which is this particular thing, and when you multiply this thing, this reduces to this thing. So finally you have this formula for the covariance of x comma y. So if this is independent, then these both quantities are going to be the same. So in that case, the covariance will be zero. So if it's given that covariance is zero, it means that your both the random variables are independent, and you can assume that covariance of x comma y is equal to covariance of, sorry, expectation of x comma y, x into y is equal to expectation of x into expectation of y. So this thing you can assume. So this is vice versa true, means if it's given that the expectation of x y is equal to expectation of x into expectation of y, this is means that these things are independent, x y and y are independent. And if it's also given that covariance is equal to 0, so covariance of x comma y is equal to 0, if it's also given, then it understands the same thing. Okay, so this is the all over thing that means that is related to mathematical expectation and all things. We will see some questions if there is something in the question paper, but for now, this is what the properties are. So do you have any confusion regarding understanding any properties or anything else? Guys, do you have any confusion regarding understanding anything? Let me know. Okay, so at this point of time, if you don't have any questions regarding what we have discussed till now. So we will see some questions from the paper itself for today, and tomorrow we'll move to the distribution section. And like distribution is nothing, means we don't obviously don't require to study distribution in depth, because means nothing more much is asked, like if you just know the PDF primitive, you can solve the every questions. So distribution may we will see like binomial, Poisson, then I think geometric distribution, then exponential, normal, uniform, all the basic distribution we will see. We'll see that PDF, PMF, whatever it is, and we will also see some examples exclusively based on like how to solve the questions using binomial theorem, what type of questions can be asked, and what type of questions has been asked. We will be just focused on that, and you'll also see some important thing, like if you have some binomial theorem, you can actually sometimes change into a Poisson distribution. So the binomial distribution you can change into Poisson distribution, and sometimes there is something called like a means sometimes these things can be changed into normal distribution also. So we'll see those formula, those rules also, like how to do those things. So these type of questions will be there, like changing from one distribution to another, or how to solve questions from binomial or Poisson. So we'll see those things. Don't worry about it. Okay. So for now, for the rest of the today, we will just start solving some of the questions from the paper itself, and the questions are like not too difficult. So just let's now start for this question. So it's given that gy is the continuous probability distribution that can be used to model y. Okay. So gy is cy square into 1 minus y at 0 y to 1. So you need to find the c, and you need to find the determine the what probability y is greater than 0.8. So like especially if these are the subjective based questions, you need to write each and everything step by step. So you have to start with this way, like if this is a probability density function, then minus infinity to infinity, gy is going to be 1. Okay. And in that case, this particular thing will reduce to 0 to 1, because this formula is given between 0 to 1, and c y square into 1 minus y dy is equal to 1. And then you can solve this particular thing, c uh, 0 to 1 y square minus y cube dy is equal to 1. And now we need to do this particular thing, just you need to do the integration, c y cube by 3 minus y4 by 4. Okay. And then 0 to 1 is equal to 1. And if you just put this value, you will get c uh, 1 by 3 minus 1 by 4 is equal to 1. So in that case, you will get the particular, yeah, so this implies that C will be 12. Okay. So if you just put 12 here, now it is going to be the your PDF. And now easily you can find the this probability of y greater than 0.8. So probability of y greater than 0.8 simply means that integral between 0.8 to 1. Why 1? Because the last limit is 1 itself. And this is the means 0, this is 1, and this is going to be c, this is 0.8 somewhere else. Okay. If you'd have been the different part of gy, let's say 2 3 different piecewise continuous function, then in that case you need to break those probability according to that. What's just here simple, you have to do 12 y square 1 minus y and then dy. Just you need to find this integration, same thing you will do here, and then you will get the required probability. So like this is just a basic question. So let's now just see another questions. I think it's clear with you all. So let me just see some other questions if you have. Okay, so this question is solved. We have already solved this. I think you all have solved this probability questions, right? Okay, so like something here is also given. It's related to, I think, the gamma distribution. But obviously, we will see the gamma distribution, and once you see the understand the gamma distribution, it will not take more than 2 minutes to solve this question, because everything will be based on like some of the basic thing only. So it's saying that just let's understand question only. It's a gamma distribution probability density function. So this is standard probability density function of a gamma distribution, and the mean and variance are given. Okay, alpha by beta, it's the mean, and variance is alpha by beta square. It's the general mean. So from historical data, the mean and variance of lifespan of battery are estimated as 4 and 2. So alpha by beta is given as 4, and Vx is given as 2. So in that case, you need to find this particular thing. Obviously, if you solve for alpha and beta, we'll get the value of alpha and beta. Okay, if you just solve for these two questions. And then these are saying that the expectation of x square is equal to alpha by beta 1 plus alpha by beta. Okay, so in that case, if you want to find the expectation of x square, just you need to follow the same rule, which is minus infinity to infinity x square fx dx. Okay, but I will just teach you what is the gamma distribution, how what is the gamma integral, but don't worry about it. And repeat the same thing like a minus infinity to infinity. So this is from 0 to infinity. Okay, so 0 to infinity x square, and if you just put the entire this distribution here and just integrate it. Obviously, integral we will use some gamma distribution properties, and then we will get this particular value. Okay, whatever this particular value is. And in that case, if you just put the value of alpha and beta, you will get the other thing also. So we will see this thing. So obviously we have not studied the gamma distribution, but obviously these type of questions will be there. Like whatever you can understand, and like some of the word problems like this. Out of a large number of cars produced in a automaker, the percentage of battery that will last for more than 8 years. Okay, so it means that it is asking a probability of x greater than 8. Okay, so in that case it will be 8 to sorry 8 to infinity, and whatever required probability is. So in that case this particular thing is going to be true. Okay, so if you just see that the any uh, anything. So this particular formula, you can see that we are keeping the same PDF here, and we are finding the required thing. Obviously, this thing is also true because if you do find 0 to 8 and just do the 1 minus this thing, you will get the same probability. So in this case, this B and C are correct. So you can solve these questions without any knowledge of gamma distribution. So means like these type of questions really that's not too hard. Just understand how to find the probability of x greater than 8, and just you can translate into this way. Do you understand why these two things are equal? Anyone? Okay, so this thing is instantly not the same thing, because here x is given, so this is going to be different this result of this thing is going to be different from what this is. So obviously the answer is b here, because if you just find this thing and do 1 minus this particular thing, you will get the result of probability of x greater than 8. Okay, do you understand the questions or not? Anyone? Do you have any problem, or if you understand it correctly or not? Guys, tell something. Do you understand it, or do I need to explain it once again? Do you understand? You did not understand, right? Okay, so simple thing. It's that key just x greater than 8 you need to find, and obviously probability of x greater than 8 is 1 minus probability of x less than equal to 8. So in that case, this particular thing is the same thing what you have now, and this questions of this thing it's not asking you to find the overall. Hello, why? Hello, hello, hello. You guys, can you hear me? Actually, I can hear you, but actually I can hear you also. Oh, there is a network glitch from my side only. Uh, Let me know if my voice is clear now. I'm audible, right? Okay, so have you solved question number 14 or not? Let me know. Anyone? Have you solved this particular questions? Question number 14. Hello. Anyone, if you can hear me, just let me know. If you can't hear me, just let me know. Hello. Hello. Okay, sorry. From tomorrow, I will just arrange another network connectivity. Okay, so I was talking about this question number 14. So, have you solved it or not? Anyone? I think my voice is clear now. Guys, please speak something if my voice is clear or audible or not. Hello. Okay, so I think for today, I think that the network is so much disturbing. So just we end the class today here, and just try to solve some questions from the probability. Like this question of 14 is there, and some other questions are there. You need to find like what are the other probability questions, and you need to solve these questions from yourself. And we'll discuss some questions eventually from the distributions. If you cover, we also discuss some more questions. But the questions that you have till now, I think you can all solve those questions. Uh, is this thing clear with everyone? Yeah. So different like this is also questions of probability, I think. So something called this is given, and okay. So let's try to solve the questions from the basic probability that I've taught, basic probability, this random variable, and then from tomorrow we will see the distribution. We will be able to solve almost all the questions from the anything related to probability statistics. Is it okay? Okay, so at this point of time, you must be able to solve questions from coding. Probability, I will just cover in just 2 to 3 days everything. And there are some data interpretation questions that you need to solve by yourself. So this not like taught anywhere, any particular data. They like this type of data type question. So I think this just you need to just understand everything by your own, and you can solve these questions based on the information given. So this will allow you to, I think, cover 30 to 45% of questions of the paper, and the rest will cover more. But obviously from probability programming and data interpretation, you will cover more than this syllabus. So a lot of questions from data interpretation, so they are not only this question. You need to find this particular question. It's from the reasoning, and uh, just solve these questions from your, because data interpretation, you need intuition, and those intuition does not come in a single day. So it might happen that sometimes you need to apply a lot of times to solve in particular questions. So like when I was preparing, there was a questions from the data interpretation, which was actually very tough to solve. So it was there was only a 1 year paper available from my time, this 2018 paper, and in that case we had a particular questions from data interpretation. Just let me show you that question. Where is it? Okay, so this particular time zone question. Okay, so these questions actually took more than, yeah, yeah, speak. Okay, so these are the part of basic statistics. So means I will cover the basic skewness and kurtosis at the end of the lecture. Like once I finish the standard distribution, then I will cover the what the skewness and kurtosis are, and some basic. Like it's has been given in the syllabus, so I should have taught these things. I thought you all are aware. So this summary statistics is given. So I will take maybe 20 to 30 minutes. It will take to cover all the summary statistics like mean, median, mode, this standard deviation and variance and all those things. Yeah. So till the time you can now solve the questions from this particular part. Obviously, from this particular part also expectation variance, and we will just start with some standard distribution and their expectations and variance from the next class. So like simple thing, it's nothing fancy, nothing. Just everything start from very basic and just you can solve by using the whatever you know. And uh, from next class, we'll start with the binomial distribution, and obviously we'll be able to solve lot more questions after this thing. Okay, so I think today is 22, so this thing should be completed by 25. So 23, 24, 25 we have. And then from the next week, we will start with this discrete maths, which is set, relation, combination, permutation. And this thing will also take 1 week maybe to complete. And from the April, we will start with the, I think, school level maths, and we'll do some portion from there also, and we'll keep solving some questions. We'll keep having tests after, means from the start of April we will start having some weekly test or something like that. Okay, so I think the website is actually accessible to all of